Hello, Bobcats. Let's talk about quantum numbers today. Okay, so to understand quantum numbers, we need to realize that electrons have designated arrangements in the atom in orbitals of specific energy and shape. That designation is as follows. First, you have an energy level, which we will call the principal energy level. Within that energy level, you will have sublevels, within those sublevels you will have orbitals, which are three-dimensional spaces, and within those orbitals you may have the electrons. So we have to place each of the electrons in an energy level, within a sublevel, an orbital within that sublevel, and in the electrons you can only have 2 electrons per orbital. Now each designation has a quantum number assigned to it. So what we're going to do now is we're going to go through each of those quantum numbers and how they are assigned to each of the designations above: energy level, sublevels, orbitals, and electrons. So the first quantum number that we will discuss is the principal quantum number. And the principal quantum number, represented with an N, indicates the energy level. So we have principal quantum number indicates energy level. And the values for those numbers are positive integers. So N equals 1, 2, 3, and so on through infinity. Right now we only have 7 quantum numbers, 7 principal quantum numbers, because we have 7 energy levels for our electrons. The next quantum number is called the angular momentum quantum number. And it's represented with a small l And so angular momentum quantum numbers. These indicate the energy sublevels and shape of the orbital. Okay. See if I can get this to look a little bit better. There we go. Okay. And the values are n-1. Or you can say that equals 0, because if you're on the first energy level, n-1 is 0. 1, 2, n-1, 3, and so on. Now, let's look at the number, the quantum number. So we'll look at L, and then let's look at the shape. And then I'm also going to indicate the name of that shape right next to that. The name has nothing to do with the shape it is. It's just where we get the letter for that name, shape. So we have a quantum number 0. That would be an S sublevel. And the S comes from the name spherical. Then angular quantum number 1 would be the P sublevel, and that comes from principal. And I will show you the shapes of those in a few minutes. I'm not going to draw them, but I will show you in just a minute. See, principal has nothing to do with the shape. It's just where we get the P from. So we have P sublevel. Then if you have a quantum angular momentum number of 2, that's a D sublevel from diffuse. And then if you have a quantum number of 3, that's an F. So you have S, P, D, and F. F comes from the word fundamental. Has nothing to do with the shapes, just that's where we get the names. Okay, so you can have an energy level 1, 2, 3, up to 7 right now, but it theoretically can go up to infinity. And then we have sublevels, and those sublevels are called S, P, D, and F sublevels. Their quantum numbers are 0 for S, 1 for P, 2 for D, and 3 for F. Then we have the magnetic quantum number, and so that would be excuse me, magnetic quantum number and that is represented with M subscript L. M subscript L. And this indicates the orientation of the orbital. So these are all three-dimensional orbitals, and they're orientated in three-dimensional space, so it indicates that orientation around the nucleus of the atom. And so let's look at it. We will have I will put over here the sublevel so you can relate to the sublevel, but this is not part of it. Then we'll have the magnetic quantum number ML. Then we will have orientation. Now I'm not going to be able to give you all of the orientations, but I will give you as much as I can so you can get the idea. And then I will over here number of orbitals. Okay, so in sublevel S, our M sub L is 0, and our orientation is a sphere. In other words, it's completely around, and so that would be an orbital, and that's one orbital. Now in the P sublevel, we have a -1, a 0, and a +1. These are the three numbers for P. And that's because we have a px, a p orbital on the x-axis, a p orbital on the y-axis, and a p orbital on the z-axis. And I'm going to underline them like as if each underline is an orbital. And so we have three orbitals in the p sublevel. And they have quantum numbers of -1, 0, and +1. Then we have our d, which would be quantum numbers of -2, -1, 0, +1, +2. And the orientations, a little bit more complicated. We have d, x squared minus y squared. That's one orbital orientation. Then we have d, xy, d, xz. We have d, yz, so that's d orbital on the yz, and then dz squared. So there's 1, 2, 3, 4, 5 orientations, so there's 5 orbitals there, and they have numbers -1, -2, -1, 0, +1, and +2. And then the last one we're going to look at is our F sublevel. Now the F sublevel has a quantum number, a magnetic quantum number of -3, -2, -1, 0, +1, +2, +3. So we have 1, 2, 3, 4, 5, 6, 7. So that means we have 7 orbitals. And I will start writing them here. That would be an F on the XYZ. That's one orbital. Another one would be F y times x squared minus z squared. And I'm not going to continue these because they get more and more complicated, but you'll realize there's 1, 2, 3, so 1, 2, 3, 4, 5, 6, 7 of them. So these are the magnetic quantum numbers of the orientation. In other words, the orbital orientations. Let me move that up, I'm sorry. Again, F has -1, -2, -3, -2, -1, 0, 1, 2, 3. That's 7 if you count across. So there are 7 orbitals, and they're F, X, Y, Z, F, Y times X squared minus Z squared, and so forth. So I'm just not going to finish writing those out. So there's 7 of them. And the last quantum number we need to look at is the spin quantum number. So it's a spin quantum number. And that's represented with an M sub S. Okay, so it's a magnetic spin. There are only two possible values. And those would be a +1/2 and a -1/2. And it indicates fundamental spin state of an electron. Sorry, state of electron. Now, what I mean here is that electrons are negatively charged and they do not like each other. So in order to, for two electrons to exist in the same space, they have to have opposite spins, just like in a magnet. So if you think about it, if I have an electron here, and we have a clockwise spin on this electron, and let's say that clockwise spin creates a magnetic direction of this direction like this, where we're looking at north and south. That's that spin. And then the other electron would have a counterclockwise spin like this in the other direction, and we would have a magnetic spin in the opposite direction. So my north would be this way and my south would be this way. And you know, north and south magnets will attract each other, but if I had it turn both spins up, the both norths, they would repel. So that's how we're able to get electrons in the same space. And this would be a positive 1/2 value and a negative 1/2 value. And we use the same arrow designation when we put electrons into orbitals. So, the next thing I'd like to do is look very quickly and make a table and then show you the pictures of each of the orbitals and discuss that in a minute. So if we look and make a table of this, so let's have a table of quantum numbers. And on that table of quantum numbers, we'll put principal quantum number in, that's the principal energy level. Then we'll put the angular momentum quantum number, which is the small l. That gives you what the shape is. And we'll also, next to this, we'll write the orbital designation, or sublevel designation, sorry. Okay, and then over here we'll put m sub l, which is the magnetic quantum number spin, or the orientation of those orbitals. And then over here we'll do number of orbitals and number of electrons. Okay, so in energy level 1, the angular momentum quantum number would be 0. That would be an S sublevel. There's only one orbital and it's spherical, so it's 0. So we have one orbital, and that one orbital can hold 2 electrons. So let's look at the next level. So energy level 2, principal quantum number 2, has an angular momentum quantum number of 0 and 1, which in other words we have an S and a P sublevel in the second energy level. Now that means we have a 0, and then we have a -1, 0, +1. For the orbital orientations, that means we have 1 orbital and 3 orbital, or 4 total for that energy level, 2 electrons here and 6 here, or 8 total for that second energy level. Let's look at energy level 3 now. So our sublevel quantum number, or angular momentum quantum number, will be 0, 1, and 2. In other words, we can fit an S, a P, and a D sublevel within that energy level, and we would have the S would have a single orbital with that orientation. P would have 3 orbitals, a -1, a 0, and a +1. So that's 1 and 3. And then D would have a -2, a -1, 0, +1, +2. So it's 1, 2, 3, 4, 5 orbital orientations. So 5 total orbitals. and this would have 2 electrons. So the p sublevel can have a total of 6 electrons, and the d sublevel can have a total of 10 electrons. And then let's just look at the 4th energy level. So if we go to principal energy level 4, we have sublevels. In the principal energy level, we can fit sublevel S, P, D, and F. Oh, it's supposed to be a 3. Sorry, 3. So that's S, P, D, and F sublevels with quantum numbers of 0, 1, 2, and 3. Sorry about that. Let me move this up. So energy level 4 has S, P, D, and F, so it can have 4 sublevels. Those have quantum numbers of 0, 1 for P, 2 for D, and 3 for F. The orbital quantum numbers, or the orientation, would be 0 for this, because it only has 1. Remember, P has 3, so that's going to be -1, 0, +1. D can have a -2, -1, 0, +1, +2. That's 5. So again, we got 1 orbital, we have 3 orbitals here, and we have 5 orbitals here. And then F can have a -3, -2, -1, 0, +1, +2, and +3. So if I count, it's 1, 2, 3, 4, 5, 6, 7. 7 orbitals. So again, that would be 2 electrons in this sublevel. 3 times 2 is 6 electrons in the P sublevel. In the D sublevel, I would have 10, and in the F sublevel, I'd have 14. Now, therefore, if I look, the energy level 4 can have 2 plus 6 is 8, plus 10 is 18, plus 14 is 32. 32 total electrons in the 4th energy level, or 2n squared. So that's 4 squared is 16 times 2. The 3rd energy level can have 2 plus 6 plus 10. That's 18 total electrons in it. 2nd energy level can have 2, and the 1st energy level, 8, and the 1st energy level can have only 2. Now, let's look at what we mean by this orientation and how this is set up. And let's look at what it looks like. So, what this looks like would be this. Let me try to get let me pull it out. Let me show you here. So, if I were to say, give you numbers here, we could say that this would be, and this time I'm going to use a pencil because I only have one of these here, and I don't want to lose it. So remember, S has 0, so this would be, S has a M sub L value of 0, and then nothing this way. And P has 3 orbitals, and they look like dumbbells, and we have on the Z, Y, and X axis, or X, Y, Z axis. And so that would be a -1, a 0, a +1. Can you see? So I don't know how bright that is, but again, you can see now how we have different orientations. This is on the X, Y, and Z axis. And then the D has a -1, -2 value here, a -1, a 0, a +1, and a +2. 1, 2, 3, 4, 5 orbitals. I say they look like clovers, except for this 0 orbital. So we have a sphere, dumbbells, clovers for the D, and then F's are kind of strange. There's quite a bit of them, so it's, remember, -3, -2, -1, 0, +1, +2, and a +3. And that's 1, 2, 3, 4, 5, 6, 7 orbitals. These are 3-dimensional orbitals. Now remember, you have to understand that the electrons are not they behave as a wave also. And waves have nodes. And that's why you see all of these funny shapes, because we're really calculating a wave function for those electrons to exist in that three-dimensional space. If you compile them all together, you would have the sphere. This is what the P would look like. This is what the D would look like. And this is what the F would look like all together. So again, this correlates to our values here that we have. If you look at it, S has 0, so we have the S with the 0. Remember P, the P sublevel has -1, 0, +1. And I should use this here. This P has, and so there's the -1, 0, +1, the PX, the PY, and the PZ. Then we have D, and remember D has -2, -1, 2, 0, +1, +2, and there's the 5 there. And I'm not going to go through the 7 again, but you can see the pattern now. So those are the quantum numbers. Later we'll talk about how we use those quantum numbers to identify elements. But first, I would like to address orbital diagrams and electron configurations. So we will finish this lecture at this point. Have a good evening.